What's up everyone, today we will start solving another challenge from DarkNets CTF 2.0 from binary exploitation category, which is Fort KNox. So as you can see here, this is the official write-up for the challenge. We have the make file so you can compile the source code. You have the flag and the binary, and you have the source code for the challenge. You can check it by yourself. Also, you have the manual exploit and the jail to sandbox the task. And finally, you have the solver. So now I will start by solving this task. The first thing I will do is I will download the binary and open it in IDA Pro and see what we've got. So basically, this is a return to win challenge. We have a function named process input running inside a while loop. We have also a gets function that reads to the buffer, and we have another function named Fort KNox that reads our flag. But the trick here is our function Fort KNox have arguments, and we should craft them in a way to bypass this comparison in order to get our flag. So all we have to do is override the return address to our function Fort KNox and craft the function arguments in a way that they match these values over here. So let's do it. So the first thing I will do is I will try to get the offset of the buffer. To do that, I will use cyclic from debug. And as you see here, our offset is 44. I will use that offset and start building our payload. Now I will use object dump tool to get our return function Fort KNox address. And this is our address. Now we should put our Fort KNox address inside our payload, and of course we should put it in little Indian format. Now I will make a breakpoint exactly in this address to check our return address and see if our payload is correct. And as you see here, our return address is pointing to Fort KNox function, which means that our payload is correct. The next step now, we will add the three values inside our payload in order to get our flag. I will start by making our first argument, which is deadbeef. First of all, I will make three breakpoints exactly in the comparison instruction to see if our payload is correct. Now we can inject our payload again. So as you can see here, this is the first breakpoint. We have our return address pointing to Fort KNox function. We will hit continue. So now the second breakpoint is in the comparison instruction, and we see that the comparison is not correct. And this reason is because we should add some junk value in order to get our argument in its place. Sometimes thing doesn't work as you expect. You just have to make your breakpoint and see how things goes. Okay, I will inject our payload again. And as you see here, we have our comparison is correct. As you see here, we have our value deadbeef correctly injected into the memory. All we have to do now is we will inject the other two values and see what we've got. So the second argument is code baby, and the last one is lead. And of course we should put them in little endian format. I think we good. And I will inject our payload another time and see what we've got. So this is the first big point. As you see, our return function, our return address is pointing to Fort KNox function. Let's hit continue and see what we've got. And as you see here, this is the second big point, and our comparison is correct. Also, this is the third, and the comparison is correct, and the fourth also. Now, if I hit continue, we should get our flag. But first, I should make a dummy flag to test our payload. Now, if I keep hitting continue, we should get our flag. And that's it. This is our flag, which means that our payload is correct. Okay. Now I will pipe our payload in the binary and see what happens. Sorry. That's it, we have our flag again. Now I will pipe the payload in the remote and check what happens. Sorry. And that's it. Our payload is correct. So we successfully solved this challenge with the manual exploit. Now I will make a pawn tool script to solve this task. First thing, I will make a pawn tool template to solve this task. This is our template in which we will customize and see what we've got. So the first thing I will put our offset. Also I will get our win function address. We can call it Fort KNox address. And now we can build our start building our payload. So I forget to mention that this is a 32-bit binary. As you see here, this is a 32-bit binary. We should take this into consideration when making our solver. I think our payload is good now. We can send it. We have the offset, the return address. Okay, we good. And that's it. We have our flag again, which means that our solver is correct. Now we will make our solver work on the remote and see what we've got. And that's it. We're good. We solved our task.